Okay, let's get started. Hello, so today we are going to talk about unlocking cloud servers. I have my second monitor here, so I will look sometimes here. If you have any questions, you can ask in the chat and I can answer in the end, or I can even stop and just answer for you immediately. So feel free to send some questions there, and that's it. So to start, I'd like to say cloud should not be hard, but I believe you probably agree with me that cloud right now, in most of the case, it's really hard. Like we need to do many things to start. But let's recap a little bit. Let's try to remember about the beginning of your career, and then what was the first deployment that you made to a remote server. I have a screenshot. It's not actually a screenshot. It's from Web Archive from my first one. And my first one was a website with my friends. So we call ourselves like the Brothers Company. And that's a broken screenshot because it's from 2007, I think. So it's a really bad website, but it was very simple to deploy. So the visual is not good, like the visual is terrible, as you could see here, but the deployment was very easy. And I think that was good. How was the deployment? I just need to drag and drop some files from my computer to the FTP. So I think it was a very good way to deploy because it was very simple. Then later, of course, I start to use some SSH to connect to my remote servers. Then I start to use SCP to copy the files. So it's an evolution, not too much, but it was the same idea. I just moved files from a place to the other. So that was in the beginning. But then I start to use some technology like Java, where I have to build first my code and then to send it to the server. So I had additional steps, and I would need to every time build my code and then send to my server. So the process was basically like this. I don't use Java nowadays, so I don't remember if it was built. I think it was not built, but it was something like run a command like maven build, and then copy the var somewhere. So, and somehow we need to have a way. It could be SCP, it could be another command. So today I think people in Java could do something like this. So you build your project and then you send it to a server. Nowadays I use more like Node.js, but it's the same, right? Usually you have something to build, and then you have like a tarball, or you have a file, or you have a minified file, and then you send this file to somewhere to be executed. So what I want to show you here, that you have some pieces in common. So what do you have in common? We have almost in every case, especially for applications, you need to build something. You need to copy something from the place where the build happens to the remote environment, and then you need to run something. So these three steps, they happen very often, or almost every case for applications nowadays, except of course like static applications or static websites where you can just copy and you just serve the files. But even in this case, you need to install some kind of proxy or something to serve the static files to your users. So we build, copy, and run. But you could also do in other way, right? We could also copy, build, and run. How? We could copy the source code, and then you could build the source code in another machine. So I don't need to use my machine, and then you can run in the same way. So the order is important, but we can change the order, and you can think a little bit out of the box. So where I can copy from? So I can copy from multiple places. For example, doesn't matter where, but I can copy from GitHub. So my code's there, right? I have a branch, I have a commit, I have a tag. I can get my code from there in a very specific version, and then I can build, and then I can deploy. I can also copy my code from a CI/CD system like Jenkins or CircleCI or Travis or GitHub Action, and they are going to copy my code and send somewhere where I can build this code. So that's another way. And I can also send from my local machine. So everything is the same. I'm just getting in some way the code that is my code that's going to produce my application, and then building somewhere else instead of building on my machine. So I don't need to install anything on my machine. I can just have my development setup ready for me. Okay, so the copy part is kind of simple now, right? Because you just need to copy code and transfer somewhere, and you know how to do that because you used to do that like with FTP, with SCP, with many commands, so it's not a challenge. So, and you can talk about build later. And now the same question, but in another perspective, like how did you run your first app? So how did you deploy? Like you send it to the server. We already talked about it. Now let's talk how did you run your first application. So in my case, I think it was Tomcat, like the real application with a server, but I'm not 100% sure, but I think so. Maybe some of you, they are younger and you are like running with Nginx from the first day. I think when I started, I'm not sure if Nginx was available at the time, but that's also an option to serve like files, maybe even static files. And one more part is like, where did you run? So in my case, I ran probably first, maybe in some like cheap server in Brazil, but I think some months later already on AWS. And I have been running servers on AWS for a very, very long time. So AWS is a very good choice for many reasons, but let's try to understand a little bit more what happens when you start deploying servers there, and then what you do next and what you do next, and how that can be a problem depending on the choice that you make. So first, usually you are running like a C2 instance. Like for those who are not familiar with this term, it's like the computing unit for like AWS. Basically, you're renting a virtual machine. It's not a like real machine. You're not getting a full machine to yourself. It's just a virtual machine running on top of a real machine, and that can have some consequences. We can talk about that later. And then you have your operational system, and then you have the internet, and then you have security groups and a lot of network layers from AWS. And in the end, what you can do, you can connect your users from the internet with this machine. So very simple, very straightforward, and that's the way probably a lot of you started like this. And then later you say, okay, this machine is not just like a generic machine. This machine has my code on it. So I'm calling this like a EC2 instance running Ubuntu, but with your application. Why this is important? Because maybe you start to have a lot of traffic and you decide to put a proxy on top of your application. So your application doesn't receive all the requests first. You can have some security rules. You can have some other rules there. And then maybe your app is growing and then you decide to put multiple EC2 instance because now you want to have like a way to balance the load. And then you have multiple proxies because now your app is even bigger and then you need to have more proxies to be able to balance afterwards your application nodes. And then you start to see like, oh, maybe there is a solution for that. And of course there is. So you start to use AWS Load Balancer and they have a lot of options. And then you start to also use some managed service to create, shut down, to manage containers. And then you end up in a setup like this. And that's completely fine. That's going to work. But I see a problem here. You stop to use like just like simple tools and solutions that are available for everybody, and then you can run anywhere. And you start to use tools that are very specific to AWS. And actually, they are not tools. Usually, they are services. Like you don't have a way to see what's really going on. You don't have a way to debug. You don't have a way to install somewhere else. So that's what we call in the industry like a lock-in. So now you depend on a lot of features, a lot of details that are attached to AWS. And that's not bad, but it's just something that you need to be aware. And because of that, we also need to pay AWS, of course, it's fair, but they can maybe raise the price because now they know everybody that's running with a lot of these layers, they are custom layers. And maybe if you need to migrate, it's going to be a very big cost that we call sunk cost, like it's going to be really hard to get out of it. So maybe you are going to be stuck in this scenario. And then maybe you're thinking, oh, but I'm not going to do that because I know that I can transfer to other services. But all the other services are going to do the same. And you have solutions like AKS here is Kubernetes, but usually you need to have some layers of configurations as well. But if you go to Google and Azure, it's going to be the same. I just use AWS because that's my example. I run services in AWS for a long time. So I was more comfortable just talking about AWS names there, but the same is going to happen anywhere. And that's not a problem on itself, but it can lead to problems. But at least you can say, okay, Filipe, I know I am stuck with AWS. I know I use a lot of service on AWS, but I really don't care because I'm moving really fast. And AWS is allowing me to move really fast. Like actually AWS services are allowing me to do that. Do you? Right? When you deploy your application, when you do everything that you do in terms of DevOps, do you feel you and your company are moving really fast? Because most of the companies that I'm talking, they are like really like they don't understand why it's so complicated, why they have so many problems, why they need to grow that much the DevOps team. So I don't see a lot of companies really happy on the way they are running their applications. Is it simple? Like it's really easy for you to change your provider, for example, or if AWS one region is down, is it easy for you to switch to another one? Like how simple is like does your team really understand what's going on? Or just one person in the team knows everything that's going on there? So there are some promises from the big clouds that I don't see in reality. I think they are good promises. I think they have excellent services, but in the end, I think the promises are empty in terms of simplicity, agility, pricing, and many other things. But let me introduce myself because I didn't even say my name. So I'm Filipe Névola. I'm the CEO of Quavi and zCloud. Quavi is a development company. We do from product to design and also develop and DevOps. And zCloud, as you can guess, probably it's a cloud. So, and if you join later, please ask questions. And if you ask good questions, I can give you $5 in zCloud. So that's a good opportunity for you to ask questions. And just or send some message on the chat, so say hi. But I am looking for your question. But today I'm investing a lot of my time in zCloud, and that's why I'm doing this talk. But a disclaimer here, this talk uses zCloud as an example, but it's just to prove it's possible to do what I'm saying here. I'm not selling zCloud. Of course, you can be curious to know more about zCloud, but you're going to see that everything that I'm saying here, I'm saying like in an abstract way. And I'm also going to talk about abstraction a lot during this talk. So use this information as an inspiration, not like, oh, this guy is just selling zCloud. You're going to see that I'm going to show everything that we are doing behind the scenes and why you're doing. And we also have the opportunity to ask some questions. So like that's why I'm looking here, but people are just sending some like claps. So you can also ask questions if you want to know more about what we are using, like the behind the scenes. It's completely fine, and that's what I want to expose here. So as a developer, as this is a career event, I want to also provide a lot of tips for your career, and I'm going to do this along the way. But you should always think about that. Like, okay, Filipe is going to talk about some problems in DevOps that could be simpler. Like maybe there are other areas in my company that could be simpler, maybe not. Like try to think about that. This is a talk that's going to make you think, I think, about a lot of different topics. And it's important to remember that when you are talking about cloud, you are talking about a big source of like cost for the companies. So as a developer or as a DevOps, I don't like to make this distinction very big. I think like we are developers, you need to know how to deploy our applications. So developers can save a lot of money for their companies. It's easier as a developer for you to save money of your company using like techniques that you're going to learn here than growing the company, because most of the devs, they don't know how to grow a company, they don't know how to sell a product. So as a developer, it's very good for you if you learn how to save money, because that is on your hands most of the time. So the first tip that I want to give you specifically about career is like the tech market right now is really focused on profitability. So if you can increase the profit of your company, you are going to be essential. And another bonus tip inside this bonus tip, you can even ask for a raise, because you can say, okay, I saved you $10,000 every month. Can I have like 1,000 for myself? So even this kind of negotiations are open to discuss, right? Because you saved some money, you know exactly how much you save, and maybe you can ask for some money. So I think that's fair. Then like that's a very good way for you to give a boost in your career, and probably your boss is going to love you because they are saving money anyway. Okay, and just another small disclaimer, you can copy everything that I'm going to talk here. almost everything that we use is open source, so you can do yourself. But I think even if you don't want to copy, or even if you don't want to implement anything that we are doing in zCloud, you should at least to think again. So I think that's the main, if you think again about any of the topics that I'm going to discuss here, I am already happy. So think again, like try to think about this just a little bit, or at least just in the moment that we are here. So think about the problems that I'm going to mention. So let's try to bring the context of this talk here. So I will try to pitch zCloud in the context of this cloud, this talk. It's like deploy complex projects like you did with SCP. So that's a way that you can deploy projects today with zCloud, for example. And you can see a lot of similarities, right? Like the SCP, you say, oh, I want to copy this folder to my environment that is in a remote location. And then here you have exactly the same with zCloud. And it's going to just send this code to our builder's server. But now what? Like what more you have to me? So I'm going to start to go very specific, and even if you want me to go further, I can go further. Is the problem is that I have like about 10 different topics to cover, so I try to just put some points that are not like available in the internet. It's just the learnings that our team had along the way. So, but if you want to know more, like every topic that I'm going to talk in a moment, they could be a whole presentation. We need most of these things that are provided by the big clouds, but you don't need to use from them. You can just, as a developer, you need to practice abstraction. So you can just abstract the context, the content, and understand what they are doing. But to do that, we need to know the pieces first. Like you need to know, oh, that is a proxy. Oh, I didn't know that. What is a proxy? How did it work? So you need to do this process first, and only then you are going to be able to simplify and abstract. So you need to be able to understand first, otherwise it's going to be impossible to do your own decisions. So let's start. So this is the first checklist that I want to cover. So we are going to talk briefly about machines. We are going to talk about operational system. We are going to talk about firewalls. We are going to talk about proxy and app instance. And also another checklist, because I think it's another area, we are going to talk about builds, metrics, logs, monitoring, and friendly management. So let's deep dive on these topics, and also just keep in mind, like friendly, sometimes you see this word friendly, say, oh, that's not important, right? It's really important, because if everything that you do, even as a dev, even as a DevOps, is not friendly for the user, they are not going to use. And that's also applied to your company. Like even inside your company, it needs to be friendly. Like other developers need to like the way that you are describing the problem, the way that you are solving the problem. Otherwise, they are not going to adopt, and you're just going to waste time of everybody, because people are going to drop your solution sooner or later. Bonus tip 2, in terms of how to be friendly, like dog fooding. So if you have some way that your product can use your product, or your product can be used by your team, or you can use the same solution in your like side project, that's a very good way for you to be sure that your solution is user friendly. For example, in zCloud, we are using zCloud. So our application that our users can navigate and see the application, it's also running on zCloud. So that's a way that it's required us to use zCloud every single day. And then we feel the pain of the users if some flow is not that good. So back to the checklist, machines. So as I said, each topic there could be a whole talk. So I'm going to just highlight a few points here that I think they are important for your career, and also some learns that you had along the way. So the first one about machines is like, when was the last time that you heard about bare metal? Like, what do you think when you hear the word like bare metal? Like, what is a bare metal? Which VM do you use every day to code from? So probably, I think your machine that you use to code is a real machine. So that's a bare metal. So it's not a VM. Maybe you run VMs inside your bare metal, but you are using a bare metal every single day. I am using bare metal here in front of me. So not a VM, right? This is a real machine, and you're familiar with it. Why I'm saying that? Because I think a lot of users, a lot of developers, when you talk about bare metal, when you talk about, oh, I am renting a machine from a data center, a real physical machine that I have an IP, that I have a network like board there that is connected with a cable, like sometimes we forget about all this, but it's very basic. Like we do like this every single day with our own machines. So it's not like a different species. Like, oh, I never saw a bare metal machine. Like they, of course, they have different optimizations, they have different processors, but in the end, it's the same. Like we are used to have bare metals, and maybe if you're running Ubuntu or some distribution of Linux, is even the same distribution of the operational system that you're going to use. So don't be afraid with the word bare metal. Just it's a machine that's not in front of you, but it's in a data center with a lot of machines in these drawers and a rack and a lot of crazy stuff, a lot of cables. But maybe you're thinking, oh, but the big clouds usually they rent me VMs like AWS, Google, and Azure. Most of the products are using VMs, not actual machines for the users. So they are very cheap, right? AWS is very cheap, and Google is very cheap, Azure is very cheap, but that's not true. Maybe you think they are really cheap because we used to use a lot of services on top of them. So for example, when you compare Heroku with AWS, of course Heroku is cheaper because Heroku is using AWS. So, but both are very expensive actually. So when you use like Vercel is also using AWS. So that's why you feel the clouds are cheap, because the other services are built on top of these clouds. So of course they are a lot more expensive, but they are both very expensive. Maybe different levels, but they are both very expensive. And as I said before, like think again, like you need to think, check the price, compare, and see what's the best choice for you. Let's talk about operational system. So operational system I think is the most simple one here in this slide. But of course, update everything, apply all the security paths. But I think the important one is like, don't do anything manually on these machines. Just apply code to change your environment. So you have this discussion between Terraform and Open Terraform, but we are using Open Terraform with Tofu. So you can use like whatever you want. I recommend Terraform. In the past I used Chef. I don't know if that's a thing anymore. But anyway, don't change the configurations with your hands. Like just apply one single command and let Terraform to handle the state and keep this state in a remote environment. And anyway, like do all this work because it's worth it, because you're going to apply change in a very reliable way. So if you don't know what is Terraform, what I'm talking about, please Google it. I'm going to just read a question here. Please tell us about protection from, for example, DDoS and other attacks, if there is any advantage in using cloud technology for this. I'm going to talk about this here. So good question, good timing. Firewall. So how to avoid DDoS and how to avoid these attacks. Of course, like you can imagine like, oh, Google, they have bigger proxies than I can run myself. But also Google is a bigger target than yourself. So you need to measure like this proportion. Google just released, I think last week, a big article saying like they suffered the biggest attack ever. So like these big attacks, usually they take down even Google or these big providers. But usually you are also not the target of this. And even running inside Google, inside this cloud, you are not 100% protected. And maybe you need to pay for more and more and more services. Then it's a matter of measuring the risk. But what we are doing here, for example, and of course I'm not putting everything here, just like some things that wasn't in my mind. So we deny everything by default. So by default, everything's denied. And then we open very specific things. So, oh, let's open this port, let's open this range, let's use this in a specific way. We also take the precaution to change all the ports. So for example, if you try to connect to our service using 22, our SSH is not there. So we change this port very often, so they are all dynamic, so you are not able to do just the basic ways to cause some problems to a server. And also even the internal service communication, we should close from the internet. So there are some ports that are open just for specific IPs. So you need to create all these layers of protection, and you're going to think, oh, but I don't need to do that if I use AWS. You need to do exactly the same, but with a different tool. They call security group, they call firewall, WAF, right? I don't remember what is the acronym stands for, but it's WAF. So they have tools. Behind the scenes, they are probably using firewall D or another tool, but they just provide more configurations for you in the UI level. But you are going to do just once, and then you can just apply with Terraform. So that's one way that you can measure. Another way that I didn't put here, but I can respond to Arno, is that you can put these rate limits on HA proxy. That is my next slide. And you can also put these rate limits for like connections by IP, connections in an interval, also in Nginx. And we do both actually. So you have two layers of protection. And as I said, like nobody's 100% protected because of course that's a lie, but you try to do our best to be as protected as possible, as Google, as these other companies. And usually everything that they discover, they publish. So you can also follow the best practices they are saying. For example, in Nginx, they discovered this vulnerability with Google, and they publish everything that they are doing. So you can do the same. You don't need to be less secure. And most of these discoveries, they end up into being the defaults in the configuration. So you can learn from them, and you can also apply configurations. So of course you need to be aware of these changes, but you don't need to be like, oh, I'm going to be not protected at all, because you can learn from them and you can also apply the change they are doing. If it's not clear, Arno, you can also ask me follow-up questions later, and you can go back to this topic of security in the end. Okay, now proxy, because it's related. We run in the first layer a few machines with HA proxy. HA proxy is a very famous proxy. It's open source, and you need to just have some precautions, like you need to have health checks working, because what it does, it tries to select the best machine to send the request. But if they don't have health checks, he's not able to know if the machine is healthy or not. So he's going to send and retry, send and retry. And maybe he's going to send to the same machine. So it's going to be a problem for your users. So you need to be sure that when HA proxy is sending the request, the node is healthy. And to do that, you need to configure the health checks. Also, I recommend to expose this stats page, especially if you are learning, because the stats page, you can see everything that's going on. You can see the health checks running, and I'm going to talk about monitoring later. You have a lot of monitors for this, but you can also do this without putting all the monitoring infrastructure in place, and you can watch what's happening there, and you can see the errors, you can see the retries, and then you can improve your configurations. But be careful with retries. Imagine that you have a client that has a post, and then this post is going to create something in the database, and then the connection failed, but it was after the post was created in the database. If you just retry all the requests, you are going to duplicate data. So if you do this, you need to be aware if your application or your client application is capable of handling like multiple requests of the same content. Otherwise, you can break the application because of this behavior. So be careful with retries in general. Okay, and I think that's the last one. This one would be the biggest one, but I decided to not talk a lot about this because I think this is one of the most popular topics that I'm approaching here. So I think you can find a lot of online, and you can also do other talks like this later. But we are using Kubernetes to manage our instance. So make sure you have good Node Affinity configurations. Node Affinity is what helps Kubernetes to decide where it needs to deploy a specific instance of your application. So, and I'm always using application here, but we also run database, so it's kind of the same in most of the case. So you need to be aware of that. As I said, like disks are tough, as I said about database, right? So you need to be careful with like when you have disks that are persisted, especially for database. So you need to allocate properly. Like it doesn't matter if you want to allocate more disk in a machine that doesn't have enough disk, or if you are using VMs on top of your bare metal, also make sure like the VMs are configured correctly in terms of the resources that are available in the bare metal. So hello, Bruno. Bruno just joined. So it's really important to think about this when you are configuring like Kubernetes. And also what we did, and I think it was a very, very good choice, was to centralize all the changes that we apply automatically to Kubernetes in an API. So we have our own API running inside Kubernetes. So this API receives all the changes, and then we have our own operator as well that apply these changes to Kubernetes. So you know exactly what we are applying to Kubernetes and how we are changing the resources there. So we are able to manage everything that happens. And later, I think I show a screenshot of zCloud that you're going to see that we track all the changes, and we also know because we have all the API calls. So we have 100% coverage of everything that's going to Kubernetes. So that's really, really important. Bonus tip 3, make smart choices. So this talk is not a talk against big clouds. It's a talk like to raise your awareness of the problems that you can have with big clouds and how to avoid lock-in, but you need to be smart. For example, S3 for me is a very good service in terms of pricing, in terms of like features, and we use S3 for some things in zCloud. For example, to store some encrypted database backups and some other stuff. So don't be like just following, oh, now I should hate big clouds. No, you should work with them, but you should not be locked inside these big clouds. And wait for the final part of the presentation that maybe you are going to have a surprise. Okay, so back to the checklist 2, because I talked about the checklist 1, that was like machines, operational system, proxy, firewalls, and so on. Now let's talk about the checklist 2. So the checklist 2 is more about the tasks that we do. So we have the machines and then what these machines are going to do. So we have different types of machines with different tasks. So this machine, for example, that we call the builder, they run Docker. So they have like a Docker daemon there, and then we send the ask for a build. So this Docker machine, Docker is the name that you call our machine, but it's using Docker. It's pull the code from GitHub or it's pull the code from S3, and then it does all the work. If you remember the beginning of the presentation, that I tell the story about like copying first, build later, and then run. That's the build later part. So we are going to get the code, doesn't matter from where, and then from this code we are going to build and deploy your application. So make sure you have a powerful hardware. Like there are some technologies that it's very like tough on the usage of resources when you build the code. Also, network is important. For example, we send the images to a Docker register that's not running inside our cluster. So you need to have enough network to download the layers and also to upload the layers in the end. And I just almost dropped my Mac, sorry. So builds, you need to isolate them from app instance. We don't run the builds in the same machines that we run the app instance. Why? Because maybe you're running an app and then a very heavy build is using a lot of the CPU. Of course, you have containers, you have isolations, but it's better to try to not run them in the same place because builds are intense in CPU and memory and probably network as well. So be careful with these build machines. And bonus tip 4 here, I said 4 is in Portuguese. Bonus tip 4, so task based. So different tasks will require different ideas. So again, think, be smart, don't just copy the ideas of others. So just try to think each task as a different task and maybe you need to have different solutions. And try to isolate, like don't run in the same machine or in the same VM because you can also run VMs on top of your bare metal machines, so you don't need to hire VMs to run VMs. But don't do everything in the same VMs or in the same machines. Like try to isolate the work because they have different characteristics and that could cause problems to your tasks. So for example, we run our build out of our cluster with Kubernetes, but just the machine is not inside the cluster, but the cluster is orchestrating the jobs inside these machines. So there are many ways to do that, but it's important to remind yourself all the time, like I don't need to do everything in the same machine. I don't need to do everything in the same way because I have different tasks to implement and I have different solutions that could be better for this specific problem. So let's talk a little bit about metrics. So today we collect metrics and send to Prometheus and also to Elasticsearch. Again, use the right tool for the right job because we have some parts that are better to store in Elasticsearch and have other parts that are better to store in Prometheus. And be aware of advanced exports, so that's also really cool. Like in this Prometheus stack, you have a lot of exporters already implemented for you that can extract more metrics than just like CPU, memory, and this basic stuff. So I'm going to show some samples now. But also you should be able to create dashboards thinking about your client. When I say client, I'm not saying just if you have a cloud like zCloud that people can run in the app. I'm saying your client can be yourself, can be somebody that's going to consume the metrics. So just again, abstract. Don't think just in terms of a real client paying money every month. So you can create dashboard, focus on specific perspectives. For example, I want to understand the requests. I want to understand the resource. I want to understand MongoDB. Because if you try to put everything in the same dashboard, it's going to be a mess. And the idea of the dashboard is to give you answers. So you need to have very specific answers. This is an example of an ingress. So you can see everything that's happening there. This is ingress, in this case is a nginx ingress. We also have another vision of the same ingress that is getting like even the path of the request and also like the response time. So you can see all this without paying for a service. There are very good services like Datadog, New Relic, and others, but they are usually very expensive. So maybe you can achieve the same level of observability without paying anything. Everything that I'm showing here is available in the cloud for everybody, so you don't need to pay money to have this. Also, Postgres, you can have like very advanced dashboards for database, MongoDB, and so on. I'm just showing like have specific dashboards for specific problems, collecting metrics in a specific way, so you can take more advantage of that. Logs. So logs are also like standards to be on Elasticsearch. Be careful with disk, like this can run out of capacity because logs tend to grow like really, really fast. And choose good retention policies like 1 week, 15 days, and always monitoring because maybe your consumption is growing, so your logs are also growing. So in the beginning of the cloud, like we had 1 level, now we have like 10 times more logs. So you need to be always aware of this. And you need to have like very large disks if you want to keep for a long time. Monitoring, like you need to monitor. I think that could be the first slide and the last slide and every slide between, because monitor is key. If you want to have a good quality of life, if you want to have a good way to sleep at night when you don't need to be awake, fixing problems, you should have a good monitor system. So there is no such thing as too much monitoring. So abuse of monitors, like create monitors for everything that you care. And always remember, like false positives are better than failing to notify important problems. Let's suppose some server is running out of memory. It's better to get a call and then you wake up in the night and you check, oh, now the memory is back. It's better to do that than to break the application that's running out of memory and like the garbage collector is not able to collect and then everything is falling apart. So it's better to have something that you need to act and then say, oh, but that's okay already, or I can check tomorrow morning, than not having the alert there. So you are very aggressive about alerts. You get alerts for everything that happens in the cloud. And how to do that? You should do that using Alerts Manager. Every slide, you're going to have this slide later, have the name of the tool here, okay? So Alerts Manager is a tool. And we also use PagerDuty. So we have people on call and we always have more than one. So you need to have more than one because people get sick, people need to do something in an emergency way. So always have more than one, and PagerDuty is the guy to make the calls to you. So it's very reliable. I use this service for more than 6 years. I think it never failed in my entire life. So you need to have a tool that's very reliable because that's going to be very critical for you. And also, don't trust yourself. Here is not just like yourself as an individual, like don't trust just your infrastructure. So your infrastructure and these monitors are good, but you also need to have some external monitors because if all the infrastructure goes down, that's going to be a problem if you just have internal monitors. So for example, use Statuscake. So we monitor a lot of things with Statuscake. We even monitor pinging IPs directly. Why? If you have a network connection, but you have a load balancer in the front, the HTTP requests are going to succeed because the machine is down, but you have replication, we have different machines. But if you ping the IPs directly, it's going to be down, and you want to know that they are down, even if the application of your clients are not down. I don't know if that's too confusing, but you get the idea, right? Ping the hardware to make sure the machine is there and the network is working properly, but you don't need to run the load balancer. You need to also check the load balancer, but not only the load balancer. And I think that's the last one about the checklists, the load balance, friendly management. So what you have in friendly management, in this case, of course, we invest a lot of money and you have a very good design. If you're doing an internal tool, you probably don't need to do at this level. But here in the cloud, you have a very, very friendly interface. That was the part that I mentioned, like we have all the changes. If you expand here, you can see all the changes of a specific version. You can see pending change. You can see everything about any change that's going to happen in the environment. And then we send this change using the API that I mentioned about the Kubernetes. So we have it right here, what was the change, and you have just a single way to send it to Kubernetes, so it's very easy to track everything that's going on, and not just us as the maintainers of the cloud, but also the client. The client don't need to ask us, and they can restore to any version using here. Sorry. So this is the page that they can restore, and that's very important because if you make something that is a mistake, you can revert very fast. And also you show metrics here, not just in the dashboards, so you can see everything that's going on. So friendly management is required if you want to have high adoption. If you want everybody in the company to like your work, to use your tools, you need to have this. Like, it's not optional, even for internal tools. So sometimes you just think about like good UI for clients, but for your operation, for your own like quality of life, it's very important to have a good management. Just yesterday, I was implementing something in the cloud to be able to monitor better if our billing was 100% correct. So it's just more details that our team can check. So it's very important to invest time also in the tools that your team is using. So the plot twist that I promised, I even posted on Twitter this, zCloud also runs on big clouds. So maybe you can think, oh my God, all this talk was just like bullshit, and then these guys are running everything on top of the service of AWS or whatever. That's not the case. But some clients, they want to run on these big clouds because they have other services, because they have credits, they have different reasons. But what we do, we get the machines, like the infrastructure from these big clouds, but you use our own services there. So we use our abstraction layer and you deploy there. So that's another benefit of like doing something like this, that you write your code just once and then you can change providers. Right now, we're running 4 different providers with exactly the same code. And that's very good for our clients because even if AWS region is down, and that happens sometimes, you could migrate him to another provider that's not AWS at all. And he doesn't need to change one single line of anything, not configuration, not code, because that's our job. We have this abstraction layer. Of course, if you are a small company, you should not do that. You should not implement like 4 abstraction layers or one abstraction layer that can deploy to 4 different providers, completely different without any change. I think that's madness. But if you want to have this, you can do it. Or you can use a service like zCloud, or you can try to come up with something. But it's very important to have this if you want to have a very big scale and if you don't want to rely on the big providers. So now it's time for questions. If you ask a question, I will give you $5 in zCloud credits, so you can try zCloud. We already give you 15 when you sign up, so you're going to have 20. And then you just need to follow the simple steps here and send me that you ask a question. And if you want to have my contact information, take a screenshot or just ask later on Twitter. But that's basically my name. My Twitter is my name as well, Filipe Névola. So I hope you enjoy. I hope you learned something. And then time for questions if you have questions. Any questions? If you don't have questions, you can just say hi, hello, hello, one hello. Arno said, thanks, it was interesting. I'm reading because I don't think it's going to be in the recording. Thank you, Arno. Wallace has a question. Go ahead, Wallace. I think he's probably typing. How does cloud providers differ than A2 or Hostinger? What do you mean by A2 or Hostinger? Hostinger, I think is I don't know if it's a Brazilian host. A2, I don't know. If you can explain a little bit better. Okay, AWS versus Hostinger. Like I never use a Hostinger, but if I know what you're talking about, I think they are focused more on like simple websites, and I don't think they have complex services as well as AWS. Like I think the biggest benefit of these big clouds is that like if they are just he's saying like bigger expensive one versus cheap ones, like $5 per month. For example, zCloud, our most like affordable plan is like $7.5 a month. So you could say it's cheaper. But like if it's a VPS, but it's just a virtual like machine, that depends on the setups they are running. I would say like in most cases there is not a big difference because the support of these big clouds is terrible, and I think the support of these really cheap ones are also terrible. So it's basically the same. But probably what they are doing, they don't have a big name to use, so they need to lower the pricing, and maybe they also lower the hardware quality or even the location of the hardware. So, but it's hard to compare like just what's the difference between X and Y. Like you need to have some like specifics that you need, and that's the way that we decide which providers we are going to use, right? So you read all the specifications, you talk with the support, we understand the SLA, you understand the data center location, and then we make a decision. But you need to know exactly what you want to do. I think it's hard to say, oh, they are bad, they are good. Maybe you want to have, for example, just some very simple machines that you want to dispose over like every week or every day. Maybe it's better to just use a very cheap one instead of using like a very expensive one on AWS. Why? Because you're going to dispose the machine anyway. Yeah, he's saying like everybody says goes AWS, Azure, Google, but $30 per month is too much just for a small app. Yeah, I don't say that, but I know a lot of people say that. But you need to understand also like their market dynamics. When you have like big players, they tend to dominate the market because they dominate the education content, they dominate like the dev marketing, they have like developer evangelists everywhere in the world. So they have a very good marketing. So they are able to convince a lot of people to use them, not because of technicalities or because the best pricing, but just because they have bigger names. I think that's the case a lot. So I think it would be more because of their names and not because of what exactly they are offering. And again, you can use combination, right? I just show you like use S3. Like you can use some services and you have a lot of clients using combinations. It's not a problem to use the big clouds, but maybe you can save a lot of money. You have a study case in our website that you can check later that we are saving like 10 times. So imagine a company that was spending like $5,000 and now is spending like $500. That could be the difference between like profit or non-profit. We have companies that are reaching us to try to reach profitability by saving money with cloud. So cloud is a very big cost for a lot of companies, and then there are many ways that you can save money even if you don't want to change everything that you're doing. You can keep using AWS, you can keep using, but just for very specific research. Any other question? If you have any questions that you don't want to ask here, or if you don't think it's appropriate to ask here, you can also send me to Filipe, or you can also send to our support email. Yeah, it's not here, but it's support@zcloud.ws. So just support@zcloud.ws, and we are going to be happy to answer. You don't need to be our client, you just can discuss. And even if you want to schedule a call, and we can schedule a call and discuss a few topics here. And we don't have any secrets, like everything that we're doing, it's 100% like available for you if you want to understand better. 2 more minutes and then you can wrap up because I don't think we have more questions, but let's wait 2 more minutes. Why don't you pay a resource dependent payment like the resource? What do you mean by a resource dependent payment like railway? I didn't get the question, but like railway, I don't know what you mean by resource dependent. Like we are resource dependent as well, but if you pay railway, we are not going to be able to live like because it's going to be like very expensive. Like railway, I don't know if they have their own like setup or if they run on top of AWS. Maybe they run on top of AWS, but I'm not sure. I'm not saying they do that. I don't have any ideas, but I would say more that we are a competitor of railway. So if your question is like why you don't, like you can deploy with rail, you can deploy with us. Our big differentiator for zCloud is support. Like we talk with all the clients like we are talking here. We have calls with every single client. We have a verification process. So we know all the clients that are using our services and we talk with them regularly. So we don't want to scale like to have thousands and thousands of clients. We want to have like a good group of companies that trust on us and to build relationship with them. So that's a big differentiator from our model to Railway or Render or other products they have. They want to grow very fast because they have investors to pay. We don't have investors. Like, we are our own investors, so we are 100% like bootstrap, so we don't need to grow as crazy, and you can do like things with like real companies. So that's our focus right now, and I think it's going to be forever. We don't want to grow as crazy. So I think we have different models of the business, and that affects the client relationship. But you can do everything basically you can do in Railway. I think you can do in Easy Cloud, maybe in a different way, but it's basically very similar. But we have our differentiators, and I think we provide more in terms of observability. So we have dashboards ready for you. I don't know if they provide that, but I don't think so. And also you are able to customize a lot. Usually these companies, when they want to scale very fast, they don't want to customize anything for anybody because they want to scale very fast. We don't care. We customize for all the clients that ask for customization. So we have custom security rules, we have custom network rules, so we have a lot of customizations for the clients. And we know how to manage that in a sustainable way. So that's not going to be a problem for our growth as well. But we want to do that. And this client, usually they don't want to do that. And just so you don't know, like I also was CEO of a previous host company 2 years ago, and there you didn't want to do customization. So it's just a business decision. It's not like right or wrong. It's just a business model. Okay, so that's it. Thank you guys. Thank you for your time. I hope you learned something. And think again. Like, I think that's the message that I want you to leave here. Thinking again, like try to analyze what you're doing, analyze the pieces, and try to rethink if these are the best choice. And if you need help, just contact us and we can help you even to make the decision to not use the cloud. So that's completely fair. We can be not a good choice for you, and we are going to be the first to say you that. Thank you. Have a nice day and nice weekend. Bye bye. Thank you, Bruno, for the opportunity. I think Bruno's not here anymore, but it was good to talk with you. Bye.